Came here, I worked in Paris at the IEA. So do y'all know what the IEA is? Okay, and have you ever seen any of their publications? So the World Energy Outlook or Energy Technology Perspectives. Have you ever seen a roadmap before? Okay, cool. That's a pretty normal answer, and by downloads, pretty standard. So everyone downloads the World Energy Outlook. The roadmaps get a lot of attention, but it seems to be from groups that are really into the topic of a roadmap. So I put together some slides and then figured if y'all had questions, we could just talk through them. But I'm a first-year PhD student here, so I work with Paul Eakins and Mike Davies. I work on co-benefits of energy systems transition, so looking at transportation, specifically around air quality, so local and global air quality concerns. So that's my deal, and I'm an engineer from background. So we'll step through kind of what goes into a roadmap, what the process is, but why people are doing it in the first place. And that gives you the basis for seeing what the results are like in the roadmap itself. So I was going to step through what ETP is, so Energy Technology Perspectives, which is the foremost publication that influences this, and then talk about the process and then what's actually in that roadmap specifically. So we won't go through what the IEA is because y'all know about it. But essentially in the Energy Technology Perspectives publication, what they do is they say, okay, if we want to reduce carbon emissions by 50% by 2050, so we want to have them. And this is meant to give us this 80% chance, not change, chance of limiting global average temperature increase to 2 degrees Celsius. Then what are the ways that we can get there? And it's a very technology focused publication. So it says what technologies will get us there in the best way. And so best is defined as technology focused, cost optimized. So what's the cheapest way of getting there? It doesn't go into perhaps practical things, you know, like politically practical or otherwise, but it's about technically practical. Can we build it? Could we use it? And then at the end of that, so you model it, or are any of y'all modelers? You're a modeler. Are y'all into modeling? So we use this ETP times model, which you probably know a lot about, Francis. It's a global 28 region model. There's supplementary models for buildings, industry, and transport sectors. And essentially at the end of it, which is what I'm really into, even though my background is in modeling, we get this wedge that says, okay, where are we going right now? So if you look at current climate legislation, you look at our current trajectory, what we think is going to happen in terms of demand increases and development, where would that take us? And this takes us to a 2050 scenario where you are emitting 58 gigatons of carbon. Well, that's not where we need to be if we want to have this 80% chance of limiting the average temperature change to 2 degrees. So to get that 2 degree scenario from the energy sector, we're talking about 16 gigatons. So that's a big difference. And so when you look at it and you say, okay, what's the cost optimized way of getting there? You get this breakdown of a bunch of different technologies and different things that we can do. And just to give you an idea of the magnitude of what this means, so in 2050, this scenario means that you have a two-thirds decrease in the economy's energy intensity. So that should say decrease there. So you're talking about per unit of GDP in the economy slicing the amount of energy used by 2/3. So that's huge. So in 2006, the first ETP was released, and people said, well, that's great. But in 2008, they said, how do we actually get there? So if you're telling me that I need to make this massive change in power generation, that bottom wedge, okay, so I need a lot of solar. Well, that's great. Is solar ready to go? What do I need to do to actually get it there? What are the big barriers in the way, and what can I, as a country government or as an industry, do to actually get us there? So ministers from the G8 countries said that they wanted to have IEA prepare a series of roadmaps that actually said this, so that we could then use that information to accelerate technology deployment. So 6 years later, 20 roadmaps were published, and energy storage was the 20th one. So they have fuel-specific ones, so let's talk about biofuels generally. And you could use biofuels in cars, presumably. That's one of the most frequent ways we talk about it, but you can use bioenergy in other ways. We also have technology-specific ones, so carbon capture and sequestration, CSP, energy storage, and then industry-specific ones. So let's talk about the cement industry. And then let's take it a step further and go to country-specific ones. So we have a couple of country-specific ones at the IEA. That talk about the Indian cement industry, for example. So really working with that country to make a bunch of actions and milestones that made sense for them that they could then implement. So there's a whole wide array of them. So each roadmap, so in that lovely little thing there, I should say I'm speaking for myself. Let me tell the camera, I'm speaking for myself, not the IEA. Everything I say is my opinion, my summary of what we actually put into these things, etc. if I was to sum it up, we answer 3 questions. We say, where are we with a specific technology or in a specific industry, depending on the focus of the roadmap. So in this case, where are we with energy storage? Where do we want to go? So this vision for the future to support this ETP 2-degree scenario concept. And then how do we get there? And when we're talking about how do we get there, it's not just about technology. Yeah, it'd be great if technology was free, if we could make it super cheap. But that actually might not be even the most important barrier to its deployment. So looking at finance, looking at policy, looking at international collaboration, you know, what kind of things need to happen. And in each roadmap, there's specific actions and milestones included. So in practice, this translates into a lot of talking and reading to really get your brain around the subject and to look at the subject from all the different countries that are involved. Having a big steering committee with global membership. So for this one, we had people from Japan. They were one of our primary sponsors, and people from the US. So on a conference call, we'd have someone in Japan, someone in Australia, and someone, let's see, in Colorado and DC, or in DC within the US. So a lot of different people getting them together. That was a group of about a dozen. And then workshops with lots of smart folks. So these are hundreds of people that over 3 different workshops that we had. 1 focused on modeling and how we model energy storage. And then 2 focused, 1 on technology and then 1 on this policy, markets, and finance. That was hundreds of people that came to Paris and sat down with us and had these really in-depth discussions about what they're seeing. So these were industry folks, academic, government folks, big diverse group, many languages spoken in the room, lots of fun, lots of interesting things that we learned from it. All right, so we looked at storage in terms of what it can do. So storage is an interesting technology to use in the system because it's not a generator and it's not a consumer of energy, but in the process of storing and releasing energy, you do consume or lose energy. So it's not like you can say, okay, we need 5 units of energy to supply demand in 2050, 2 of those are from storage, and you know, what do we need to do to get it there to make it cheap enough to get into the system? It's much more nuanced than that, and actually ties like every different piece of the energy system. So it's from supply side to transmission, distribution to consumption, and we had to cover all that. So we looked at what could storage do to support the vision, and we broke it down in terms of 5 different things. So improving energy system resource use efficiency, looking at integrating this higher level of renewables, because in the future ETP scenarios you're using a lot of renewables and you're using a significant amount of variable renewables, which I'm sure y'all are familiar with if you've seen any of the analysis that comes out of IEA around this. And then looking at supporting greater production of energy where it is consumed. So this is distributed generation. It's also smaller communities that are isolated, island communities, etc. Increasing energy access. So these 2 are actually related but different. So the IEA is working closely with the UN Sustainable Energy for All initiative, and so it's an idea of how do we get energy into places that don't have access, you know, to it, or do have access to wood to burn, but we want to get them on electricity because there's a lot of benefits from that in terms of environmental standpoint, etc. And then improving electricity grid stability, flexibility, reliability, and resilience. So these were the 5 different categories we looked at. And we looked at a lot of technologies. So energy storage in the roadmap, and this is one of the things that I haven't seen in other roadmaps that have come out by different groups. We covered technologies that are both electricity and thermal energy storage, and this is defined by their output. So they take in heat or electricity or whatever, but it's about what they put out on the other end. So do they release electricity, so that'd be a battery, or do they release like heating or cooling capacity? And that could be a pit that you fill with water and you heat up and cool down, or it could be a brick that you put into a storage heater on the wall and you heat up and then release that heat later. But it's about both of those sides. So we looked at small distributed designs and large centralized designs. You've got the huge molten salt piles and pumped hydro storage dams and all this. But then you've also got a battery in a guy's garage that's taking in electricity from his solar panels, etc. For the thermal side, just as some examples. So this is the, we looked at residential hot water heaters with storage tanks. So you guys are familiar with big tanks of water. In some countries, they've gotten rid of tanks over time. It's space. I mean, in London, I don't know if you know, in London, do people get rid of their storage tanks?
Yeah, something like since 1984, about 50% of the hot water storage
in
British flats has been removed.
Yep.
Completely.
And that's, I mean, precious space that they just don't have to have anymore. In some countries, they're putting in more and more storage, and it's not just in their residential water heaters, not just for the hot water, it's actually for having water stored on site. So when they get cut off from any kind of whatever their water supply is, whether it's domestic water supply or other, they can, you know, tap into that 40 gallons. But so you've got a big diverse thing there. But that's an example. People asked a lot during the process, what do you mean by thermal energy storage? And I was like, actually, a lot of times I'm talking about pretty basic things, which is one of the findings we'll get to in the roadmap, which is that thermal energy storage is perhaps the one that makes the most sense in the shorter term, and it's already economic now. It's about using it, but we'll get there. So, pretty picture that I'm really proud of, because we put this together and it took a bit of time. So talking about what we're doing in energy storage and in this roadmap, it's everything you see on this paper. So we've got supply, transmission, distribution, and demand sides of the energy system. So for example, you've got a housing community that has underground energy storage, so big boreholes in the ground that you fill with water, and you use all the properties of the earth and all this stuff. You've also got little batteries or hot water tanks on houses. You've got cold water storage, which is literally just having a tank full of cold water that's useful. You've also got flywheels and batteries and all these really big things on the supply side. This is where a lot of people stop, or they think only this, or if I actually have a house with solar, that's what I think, and I don't think about the rest of it. But we went through all of it. So the thing that I say over and over and over again, which I say it because it's really important. Like, I don't really care about storage. I care about what it does for me. And I care about the service that actually can do for me and what it can enable me to do. So we looked at storage from the context of its service, its application in the energy system. And so when you look through this picture, what it's showing is that you have applications that are on the second basis or that are on a monthly basis. You can have energy that you store and you keep underground for months, and it's a seasonal kind of concept. Or you can be shooting little, jolts of power into the electricity system. Both are really useful things. Both have different values in different energy systems. So from a modeling point of view, this is super complex and gives you headaches, but it's a really important point. So you've got a technology and you say, what can it do? So not only what can it technically do, but what can it operationally do in my system over the course of a period of time. Today, when you look at grid-connected electricity storage, and in our modeling we emphasize this for many practical reasons. It's mostly pumped hydro. I think this is pumped hydro, and that's everything else. And that wedge is increasing, but one big plant on this one makes this increase a lot too, so the wedge stays pretty narrow. But this is what it looks like today. Now, I don't have a similar graph on what thermal energy storage looks like today, in part because of debates over what should be included. So is my residential water heater, is that storage? If it's being used as storage, then maybe so. So in France, they use residential hot water heater storage to take about 5 gigs off their peak demand. That's storage, or maybe not, because the purpose of putting it in wasn't that, it was so I could have a hot shower. So there's debates over that, but also because the data are just incomplete. So we might have it for 1 or 2 countries, but if I'm doing a global roadmap, I can't say, these 2 countries have that, isn't that cool? It's like, no, there's a lot more out there. So what I can say, though, is that technologies, if you look at them, so this axis here is talking about capital requirement, so how expensive it is for a unit of it, for an actual station. So a pumped hydro power station is going to be really big. So per unit, it might not be that expensive, but it's a big facility. And then technology risk, which is kind of it's a proxy for how mature it is. If you take those things and you plot them, this is actually modified from some work that Schlumberger did on hydrogen. We worked with them in part on this roadmap. And we said, okay, where are things? So you've got something like hydrogen, where you've got, a less mature technology. Yeah, we might have done it, but there's still a risk associated with it. We're not really sure how it's going to deploy all the way over to the deployed. It's out there. We know what's going on. It's a matter of finding sites for it in the case of pumped storage. We've got a bunch of batteries along this. So you've got the batteries that have been deployed that are actually in this level where they're about to become commercialized, we think, or we see. So sodium sulfur batteries are already being used on a large scale compared to where they were 5 years ago, but they're not so common, like pit storage. You see that, you go to Denmark and you see this hole in the ground that, well, you wouldn't see the hole. It'd be covered with something and it's full of things that store thermal energy. So this gives us an idea of where we are, and when we look at actions and milestones where we need to invest, this helped us to kind of plot out, okay, these guys are on the cusp, so we don't need to probably invest in basic R&D on them because they're already out here. But these guys, they aren't as far along. We're still not sure. Like thermochemical energy storage, there's a lot of potential, but how it's going to work, I don't know yet. There's a lot of potential for it, but we got to figure that one out. So I didn't go through all of the details on this because it's in the roadmap and it's a lot of words. But something that as the IEA we did, because we're working with all these different countries, someone in the US, someone in Germany, someone in Japan, someone in South Africa, they were all in a room for a workshop. They are not maybe aware of what other countries have already done. So this is a big part of the IEA's work in international collaboration. So what we did is we actually, in the roadmap, produced a list of technologies and locations in the energy system where they would be used, etc. But we included example projects. And for each of these example projects, there's actually an annex to it that's online that outlines this is where it is, this is how it's used, when available, here's the cost information on it, here's the company that runs it. So if you are in your country going, I have a similar setup to this country, my energy system kind of looks like them, they're using a lot of this type of battery, maybe I'll contact them about that. And I'll have an example of where people are already using it and have already been using it for long enough that there's information that was published on how it performs, etc. So these aren't like really early stage demonstration projects. These are like functional projects that people are using very much outside of the laboratory. All right, so when you look at the vision, so the first question was like, where are we today? So now, where do we want to go? When we look at the vision that we produced and released with this roadmap, we were looking at this high use of variable renewables energy future. Lots of graphs, you see them all through ETP and all over the internet at the IEA site. And we extended that into a vision for energy storage. So we did a few different scenarios. So the first bar you see is 2011. So this is where we are. And I should clarify on this, this is grid-connected large-scale energy storage, because these are the things that we could practically model. So we had a meeting in January a year ago where we sat down with a bunch of really smart people who had done energy storage modeling for a while, and we said, okay, what can we really accomplish in our timeline? Given our data, this was actually the biggest one, so the data that we have and the level of granularity that we have there, what can we do and actually feel like we're saying something, as opposed to putting in so many assumptions and so many proxies for things that we don't really know what our results even mean. So we said, okay, we're going to do grid-connected large scale. There's an annex actually to this that goes into real detail on all the assumptions around this. But what does that look like? So 2011's here. The next one is our 2-degree scenario. So we said, what if energy storage was used in the 2-degree scenario to meet the variability needs that we know we're going to have? So what we did is we took hourly solar production data and hourly wind production data for these 4 areas, because we had those data for these areas. And what if energy storage was used to meet all the variability needs? So all the intermittency, all the little bumps in the road, let's just fill them all with energy storage. There are other technologies that could be used for that. There's other non-technology options that could be used for that. But what if it was energy storage? What would that look like? And we took for this is saying, there's a whole cost assumptions thing. And in this one and the next one, so we took pump storage hydropower as the kind of baseline. We're saying like, this is the, no, we took today's cost in this one. In the breakthrough scenario, we said, what if everything could get down to the cost of pump storage hydropower? So what if everything could get down to pumped hydro? And if that happened, what kind of extra deployment would we get? Because again, it's a cost optimized model. And then in the next one, we actually looked at EVs, so electric vehicles, and we said, okay, what if electric vehicle batteries, which yes, are a form of storage, but again, this argument over definition, so the point of the car is to drive and its mobility, but it has a storage capability with it. So what if EVs were actually used to flatten out a lot of these bumps, so a portion of these bumps. So a certain amount of the battery capacity in the car was used. So this, in essence, shrunk the bar because we're having EVs cover this additional space here. So where we are today, where we could go in the future with kind of today's costs, where we could go if we got really cheap, but not free, but really cheap. And then where would we go if we actually had one kind of competing demand response option? Does that make sense? Okay, and it's over those 4 different areas again, because we wanted to stick within the bounds of the data that we had. Yeah, what's up?
Just to be clear, the EV scenario has the same cost as the breakthrough scenario for the non-EV batteries?
The EV scenario has the same cost as the 2DS scenario, so the light green bar. Right. So it's not the extremely optimistic. Yeah, you got down to PHS. And I shouldn't say it's extremely optimistic. We could get there, and some technologies are getting there. And at the end of the day, it might not matter because it's about how they're used operationally. Their cost is like well, that's cool, it costs that much. I don't really care. I care about the application that it's used for. But yeah, that's the light green bar to the purple. And I'll triple check that, but I'm pretty sure that's right. All right, so key findings. The first one, unsurprisingly, because we wrote a roadmap on it around ETP, but storage can support energy system decarbonization. The second one is that the optimal role for storage varies widely across regions. So even with looking at these 4 regions, when we looked at actually how energy storage would be used in them, very, very different. And when you're looking at electricity and thermal energy storage, I mean, an area that actually has district heating and has has a huge industrial base with a lot of waste heat, that's a different thing to electricity, and you've got a bunch of wind that's generating in North Dakota in the US, and you want to move that around. Some technologies are already competitive. Others, particularly on the electricity storage, are still too expensive. So even if they can be used in an operationally optimized way, they are too expensive, many of them. Some of them aren't, but many of them are. We saw that overall thermal storage had a lot more of those already cost competitive, already makes sense. Electricity storage had more of the still too expensive. We supported R&D to reduce costs on a lot of those technologies. But we said that power markets really are ill-equipped to compensate storage for the things that it's used for. And this was a key point. It's saying, what if storage was free? Well, in some countries that doesn't actually matter, and it's treated as free anyway. So in some countries in South America, for example, we found that a facility, so you've got a hydropower facility that has some storage, so it's storing energy at the top. It is required to supply ancillary services. It is not compensated for it. It is told you will keep 5% of your capacity in reserve to supply these services and you won't be paid for it. It doesn't matter how cheap I make storage. It's not going to get paid. So, that's a system where you can't fix it with a technology solution. But you can look at the policy, you can say, what if we were able to compensate it? Does it provide an advantage that the country wants? And then they can pursue that. But one example, as an engineer, I was like, man, I could get this down to 0. It doesn't really matter. Well, that's frustrating, but there you go. And then thermal energy storage, we actually looked at these as a really great way to reduce wasted heat in systems. So there's actually a industrial heat group at the IEA that looks at this. And one of the things that we came up here is that there's a lot of wasted heat out there. Problems are we don't know exactly where it is in some cases, or the actual quality of that heat. So what temperature is that, what pressure is that, etc. And then actually lining up that supply with demand. These are questions that we haven't quite figured out, and we're trying to figure out through this process. But in our analysis, just the crude back of the envelope stuff, thermal energy storage has a lot of potential there. So there's lots of actions, and I put some up. There are technology-specific actions. So for batteries, these are the big things that people need to be looking at, etc. But we did some actions that were spanning across technologies and applications, and the first one was actually addressing data challenges. So if we want to be able to provide a robust analysis around energy storage and how it should deploy, or where it should deploy, or what we should be looking at, it's really hard to do when you don't have data that can support your claims or your conclusions. So for example, on the when we were doing the analysis for grid scale energy storage, and we talked about the variability in wind and solar, that's hourly data, and that's a great data set we were so happy to have. If you really wanted to look at all those applications, remember we went down to the seconds, I don't have data that can go down that far, so I don't know what the variability is on that level. If I was trying to do that globally, even if I had the data, that would be a massive modeling task. I can't imagine running it. But if we had the data, we could analyze it right now. We can infer things, we can make educated guesses, but we can't say this is what the model's telling us. So there were other things, but you see the first two are addressing data challenges, then establishing data cooperation. So some bits of it are about talking. So this is why we included so many examples around different projects that exist, was to say that such and such countries are already doing this, and they're happy to talk to you about it, in part because they've already developed an industry to support it. So if your country uses it, they get to export some stuff, and that's great. So it's a win-win there. But you can also learn from them and learn how to apply it in your country without having to create that industry or create that research. So lots of different recommendations. On the policy and regulatory frameworks, I wanted to bring this one up just because we talked about specifically this whole price distortion concept, and if you're into price distortions or market rules and stuff, there's some great publications at IEA that have come out in the past couple years around this topic that I could send you to. But it's essentially saying the value in storage lies in the applications it can be used for. The ability for storage to make money lies in it being able to be paid for those applications, those services. If you can't line those two things up, the conversation's pretty moot. It doesn't matter. So we also talked a lot about, and this is something I want to highlight because I like these concepts a lot, it's about retrofitting and using the things that we already have better. So again, back to the France example, they use residential water heaters to get 5 gigawatts of peak reduction. That's through like a little switch. So you take a shower in the morning, and then it doesn't heat it up again until later, so after the peak. Because it's saying, you know, you don't need to take another shower right away, presumably. But if you do, you can hit this other little switch and get hot water again. That's great. This isn't a really sophisticated result. It's a little retrofit. Other parts of the, so in the US, it's in Kentucky, they actually use remote radio signals, the same thing that they use with cycling air conditioners on and off. They use it for working on heaters and for telling it when to store, when to actually directly use, and when to turn yourself off, because we need a little bit of a break on the system. These aren't super sophisticated things. We already have the infrastructure out there. We need little bits of changes and little bits of operational changes to actually use them, and then a little bit of technology like a switch or a radio or an antenna. That's a lot easier than siting a new pumped hydro facility and like finding a mountain. But so that's throughout the roadmap too. Another thing that we do for a long list of reasons that I'll just leave with, shorter term actions and milestones are often more impactful than saying in the next 40 years, the next 30 years, you need to do this. We say, okay, in the short term, these are the key things that we think need to be done in order to jumpstart this whole system. So this is the retrofitting of existing storage facilities, developing markets that actually allow storage to be paid, etc. We also talk about supporting targeted demonstration projects, because for some technologies, in order to prove how they can be used, they need to be built at scale and used. So figuring out areas in which that can be done. Anyway, so those are some of the short-term ones. It's in the very beginning, actually. There's a key findings and key actions right at the very beginning of the roadmaps, and it's just listed out. So if you don't make it past like page 3, like, you have them. They're there. So you get some acknowledgements, a table of contents, and then bam. So yeah, that's it. And actually, this is to your question, sort of. It doesn't bring up everything. When we talk about declines in costs, this is what we're looking at. So these are current cost range across the technologies that we used, which was, we actually included pumped hydro, case, and then a variety of batteries, so kind of a generic battery, where they are today, the 2DS cost target, and then this breakthrough scenario. It doesn't throw the other one, but there you go, some cost information. But yeah, so thanks. That's it. Do you guys have any questions, or what do you guys do for research, if you don't mind me asking? Yeah, I know about your one. Francis's name might be in the front of the roadmap, because he might have helped us in one of our workshops. Yeah, some nice people at UCL let him come and help me out. But what do you guys do in your work or in your research?
Renewable energy.
Okay, cool.
From my country.
Okay, what's your country?
Malaysia.
Malaysia, cool, cool. We had one representative from Malaysia at our energy training week that actually talked to us about storage. It was an interesting conversation. So, I mean, what do you do?
District heating.
Okay. Okay. So you might know the District Heating Networks group that does all this industrial and waste heat stuff.
Yeah.
Yeah. So Araceli Fernandez is she's Spanish, obviously, and she works on this stuff. She's from industry before. And it's interesting. And then one of our modelers who actually did this stuff, Luis Muñera, is from Imperial, and he did district heating stuff in his PhD before he came out to join us.
I did actually have a question around that kind of scale. Because if you want things with like the national grid scale, but if you're looking, quite a lot of the solutions are quite kind of district.
This is my question as well.
And I was wondering how you cope with that, and whether if you're modelling at the national scale, you're actually sort of making it harder for the decentralised initiative to see the value that could be generated.
Yeah. Yeah. So if you read the modeling section, there's a lot of words that we put in the very beginning to say, we're modeling this for realities that we're doing a global analysis, and we have these data, and there it is. But this is in no way implying, or we hope that no one thinks that it means that we're saying there's no value in the rest of it. So the vision section in this roadmap is actually really short compared to other ones. And then we go into recommendations that are around other things. Regional and local modeling, I think, is absolutely a necessity. And one of the recommendations we have in here is, it's called a free zone for using these technologies. So we had some representatives from some African countries that were saying, hey, I've got an area where you can test a lot of distributed, completely off-grid. I can guarantee you your off-grid kind of stuff. And I've got this one facility that actually is producing waste heat. And so if we could figure out a way to use that, that would be pretty awesome. And so one of the proposals in here is to say, when you do these targeted demonstration projects, do it in an area that's free from not only technology interference, you can't see how that technology actually works, but also policy interference, and test it out and then publish the data. So we as a global community support that, and then we all have the data and the information from it. But yeah, sure, when you're doing global analysis, you can cover up, or you're not highlighting regional differences. In there's 3 case study examples of countries. So one for the United States, one for Germany, and one for China. Do you mind if I look at it real quick? So it's in the vision. So the vision of our modeling is really short. But if you look starting on page 31, so granted, we talk about high renewable electricity future in the US. That's still really a large area. But the next one's Germany, and that one actually has electricity and thermal energy storage. So that's on page 33. And then China was our last one, which starts on page 36. So it's not the really small area and not super distributed kind of applications to your question, but that was our attempt to show that global's cool, but what we really think, and it's one of the recommendations that we highlighted in Spanning Across, is saying, you need to be doing this in your area with your mix. And we say it, I felt like a broken record, kept saying there are regional differences. Like, what does your mix look like today, and where do you want to take it in the future? That's going to give you a whole set of answers that is very different than if we just generalize for the whole world. Because I mean, Africa's one region. Like, there's Africa, it's one region in our model, and we kind of copper plate the whole world. So that's not, I mean, that of course takes you away from stuff. Anyway, that was a long answer. Hopefully helps.
Yeah.
Yeah, anyway. Do you have any other questions?
That was kind of my question.
Okay.
So it's kind of been answered already.
Awesome. One cool thing in the Germany example, they just, was it last year or the year before now? The last 2 years are kind of a blur in energy storage in my head. So within the last 24 months, Germany approved a small-scale distributed energy storage subsidy. That is all about, so they supported all this, distributed rooftop solar. That's great. Now you've got a bunch of, what is it? Not just through that, but you've got a bunch of production in the north, demand in the south. You're not able to get it there. Okay, how do we manage it? Storage is looked at as one of their main ways to do it. So they put a subsidy out for small scale residential, like tie it up to your solar panel to essentially take yourself off the grid storage. And they also put out a bunch of funds that were in support of recovering waste heat, but lower temperature waste heat, to say, okay, we've got a bunch of waste heat that we're not using. Even lower temperature could be really useful in some applications. So let's get that lower quality waste heat and see what we can do with it. So they've been putting out subsidies around this. The idea being to essentially perhaps take their country off the system, be like, we are doing our own thing and we are able to supply all of our demand.
In the UK, they've kind of renewable heat and set all their heat and centres is very much on the generating.
Yep. Yep.
I think storage is one of those things that's fallen through the cracks. That it's one of those things. It's not a demand source. It's not a generator. No one knows where it fits in the system. Doesn't really fit with existing regulatory and market frameworks. People aren't rewarded for the services that storage provides, so no one builds any.
I know, it's really funny, but as you were saying, and as you've shown, it's like what we've always been doing. Like, we've always had thermal stored in homes. So now that we're ripping them out, and then suddenly you're like, oh, maybe that wasn't, we should have been paying for the value of the service they provide.
Absolutely.
It's really interesting. So yeah, and I find that under the price distortion, which shows that mismatch between...
It exists. Okay. Yeah, no, in the UK, we had some people from National Grid. We also had a meeting that was in London. What is the distribution? You don't just call them distribution company here. There's like a couple of different distribution networks for the local, like London region. Those guys. UKPN Power Networks.
UK Power Networks.
Yeah, those folks. Apologies to them if they ever see this video, because they were nice guys. But they came in and they were like, hey, it's not even just about compensating it, it's who gets compensated for it. So I have the ability to own it. I don't have the ability to compensate for it. He has the ability to compensate it, but he can't own it. And we can't talk to each other because that's illegal. So how do we manage that? And I was like, wow, that's just a whole ball of wax. And this is, in the UK, y'all are emphasizing electricity storage. There's this, what is it, the UK Electric Storage Association, or whatever it is. They have their big target and their beautiful graphics, and it's all electricity storage. And it's one of those things where it's like, that's awesome, but you've got a lot of heat that I hate to say is free, but you're actually paying to get rid of it in other ways. So what if you don't? And the reality is it's hard right now, and it maybe shouldn't be, but it is. But yeah, I'd be happy to put you in touch with some of those guys if it's helpful to your research, because they love to talk about it because they want someone to fix it. They're like, please fix this, because if we could figure out a way for people to more often and more easily make money, especially off of waste streams. Right now we have to pay to throw it away. Well, what if we just start using it? Kind of like the cook oil out of fast food restaurants that you used to be able to, people like begged you to take away, and now they actually like, oh, you want to make biodiesel out of that? Well, you got to pay me something for it, right? Man, like they would love to turn their waste streams into profit streams. Like that'd be awesome. And companies would love to be able to, especially here where we have an isolated land mass, right? Where it'd be nice to just be able to eliminate a waste stream and use it for something useful. Like that's like a double super positive. So there you go. But yeah, anyway, that's all I got.
Thank you.
Thanks for coming.